So on page 22 on the bottom, we did that yesterday. So not to negate it. It's just it was kind of long and it took a while, and there's a little quicker way for us to decompose this fraction. So we're going to put the answer we got down from yesterday, but go get it another way. So can you guys flip back, because I don't remember exactly what we got it to be. We said, I'm just going to write it over on the side here. We said that when we decomposed it yesterday, and we said we break it up into a over one of the factors. It's basically crisscross applesaucing it. What did we get for the top? For the A, it was a 3. Okay, and what did we get for the B? 2. So we're going to go get those same answers. We're just going to use a little more streamlined method. And then again, tomorrow I'm going to give you the super, super, super duper shortcut, which is very, very, very dangerous. But I like it. All right. So this is the exact same fraction from yesterday. Remember, actually, go ahead and put this on here. Our goal is really to integrate it, but as it stands, you can't. You'd get stuck. U sub won't work for you. So what we're going to do is try to break it into two separate fractions so that I can use some natural log properties. So the gist behind it is you still start it the same way we did yesterday. So you still take this 5x minus 4, and I already know what the answers are going to be. They're going to be 3 and 2. We're just going to get them a little bit cleaner. So you're still going to take the integrand right here, and we're still going to make it some number over x minus 5 plus some number over x plus 2. That is not changed. But so basically, remember, this came from doing crisscross. The bottom came from applesauce. It's just you cleaned up your crisscross. So what I would even challenge you more so to do is think of multiplying everything through by this denominator. That'll make it, when they get more beefed up, the denominator will go on the left and you get 5x minus 4. If you multiply by that denominator on the right, for this one, the x minus 5 would cancel, and you'd get x plus 2 times a. And you can go ahead and just write it like that. But again, it's just crisscrosses, really. But if you picture multiplying through by the denominator, on this one, the x minus 5 would cancel, leaving that. On this one, the x plus 2 would cancel, leaving the x minus 5. So either way, yesterday at this point, we distributed the a's in, we correlated coefficients, and we figured out what a and b were. I'm going to have you actually do a little safer method. It's called strategically choosing x. This equation has to hold for all values of x in the entire world. All right, so what you're going to do is strategically choose your x so that stuff wipes out. So what I'd like you to do, so what I'm going to have you do is go ahead and split your screen. And what you're going to do is choose x values that will eliminate an entire chunk. Basically, you're choosing x values that make one of these a 0. So what I'm going to do is strategically let x equal -2. What that's going to allow me to do is figure out what b is a little quicker. So when I let x equal -2, I go ahead and I put it right here, and I go 5 times -2, -10, -4, -14. When I let x be -2 over here, this whole thing goes to 0. That's why I'm strategically choosing it to wipe out all the a stuff. But when I let x be -2 on this factor right over here, I get a -7b. So what's b for sure? 2, exactly what we got it to be the last way, but there's no solving a system of equations. It's a little cleaner, and less likelihood that you make. Wasn't that kind of slick? So to get the a, I'm going to strategically wipe out b by strategically letting x be the one number in the world that'll cause that entire thing to disappear. So I'm going to actually, on this one, just set x equal to 5. I'm going to write down the resulting equation. So it's a little, some books don't teach it this way. I like this way better than yesterday's. I think it's a little cleaner. So when I go let x be 5, I get 25 minus 4 is a nice 21. When I let it be 5 over here, all the b's go and I just get 7a. And I don't have a system to solve. I just get a simple linear one variable equation and I get a is equal to 3. This is my method of recommendation for some of you. Tomorrow's method will be my other recommendation. I wouldn't use yesterday's. All right, so we got the exact same answers. So what that allows me to do is once it's decomposed, it can easily be integrated. Because I just said, I'm going to go back up just so you can see what happens here. I just said that the integral of 5x minus 4 over, was it x minus 5, x plus 2? Okay, thank you. X minus 5, x plus 2 dx, I just decomposed it and I made it something over x minus 5 plus something else over x plus 2. I know they were 3 and 2, but I just totally had a brain fart as to which one was which. Which one went on the top of this one? Was it the 3? Okay, so 3 and then 2 and then dx. So the reason that's super helpful is because now that it's decomposed and uncrisscrossed, by the way, if you crisscross applesauce this, don't do it in your notes. If you go Chris, you get 3x plus 6 plus cross 2x minus 10, you get 5x minus 4 over applesauce. Do you see the solidity of the validity, I guess, of the decomposition? Anyway, this is easy to integrate because it always goes to natural log. So if you picture the 3 out front, it'd be 3 times 1 integral of 1 over x minus 5. So that's 3 ln absolute value x minus 5 plus 2 ln absolute value x plus 2. And these almost invariably go to natural log. You do have to be careful though. So if you tuned out, tune back in just for a second. I'm going to go, I'm not going to, yes, thank you. Carl, that's not what I was going to say tune in for. But watch, don't write in your notes. Had this been a 4, how would the problem change? I would have a 4 here for sure. What else though? I need a fraction correction because the derivative of this is 1, so I'm safe, but the derivative of this is 4. So I need the 1/4 correction, and so that gets missed a lot. They anticipate that on your multiple choice questions, so you'll think you did it right. So just be careful. If you're integrating this, 8 over x plus 2 dx, that is 8 ln absolute value x plus 2. Right? Because u being x plus 2, du is 1 dx, so you're great. But had this been a 5, then it's 8, what? Fifths. Yeah, there'd be a correction. You shouldn't really need to be writing that u sub out for the simple anymore. All right, so a little heads up. Keep in mind, always check for u sub first. Just derive the bottom, hope it lives on the top so you don't have to do this. For you to be able to do this, without an extra step that we'll add tomorrow, the denominator must be of higher degree or higher power, whatever, higher, let's just write higher degree than the numerator. So know that. Also, for our purposes, we are only going to work with what we call non-repeating linear factors. This is what is in the specs of the College Board Calc 2 program. However, were you doing this at like the U of M, you would have repeating linear factors and you'd have some that aren't linear. All it does is make the algebra take 10 times as long. We're going to do that after the AP exam. So we're not going to muddle things right now, but I will teach you that. What I mean by non-repeating is on your denominators, they will be either explicitly like that, non-repeating all linear factors, or you might need to factor them first to get them to look like that. But here's what I won't give you until after the AP exam. Here is a repeating linear factor, because x minus 1's in there twice. I also won't give you like a quadratic factor like this, unless it was x squared minus 1, because then I could make it non-repeating linears. Does that make sense? So I'm going to keep it easy for you, only because I know that when I had to actually revise the syllabus, so I had to really go look. I was up for audit this year. Do you know that when you're an AP teacher, you can be audited? And so they do like a couple subjects a year, but then within those subjects, random people are selected. So calculus and world history were under general audit this year, and then mine got randomly picked for super audit. So I had to go in and make sure that my syllabus had every exact thing that's necessary. And so I had to go revise it. So I actually had to read through all their specs, which is really a pain. I mean, there's a lot of stuff in there, but it's good. I mean, it was a good learning experience, but it did actually explicitly say non-repeating linear factors, which was good. Anyway, so let's go to the next example. You have one on the top of your next page. I'm going to have you cross off. So we go at the one where it says 8x plus 32. You can cross that off. This will be your second one. We're going to do this one, another one. They're all for a reason. We're going to do basic, medium, and then I'm going to actually have your third one be different. Uh, so let's begin. First of all, always go for u sub. In your brain, take the derivative of the bottom. You get 2x minus 6. Had the top been x minus 3, that's a go, right? Do you get that? Because if your d was 2x minus 6, you can make it 2 times x minus 3, and you could do a half correction, and had that been an x minus 3, you can almost do it in your head. But it didn't work. So this is a candidate for decomposition. Here's why. On the bottom, I really do have non-repeating linear factors. It's an x minus 1, and it's an x minus 5. The degree of the denominator is bigger. So this is one where you go, oh, I'm going to try decomp and hope it works, and it is going to work. So remember what we do with that. Our goal is to break it up into something over x minus 1 plus something over x minus 5 so that I can use natural log and be done with it. So what I'm going to do right down below. So I'm going to figure those somethings out, but let's use our new method of strategically choosing. So let's go ahead and that I'll fill in later. I'm going to go do a little workspace. That's my answer. If I had to guess right now, I'd guess something that had ln x minus 1 in it and ln x minus 5 in it. That might be, if there's only one, I'm done. But let's go break it apart. So we've got our x minus 4 over x minus 1 times x minus 5. I'm going to uncrisscross applesauce. I'm going to figure out what must have been on the top of the x minus 1 factor, what must have been on the top of the x minus 5 factor, so that when I did crisscross applesauce, I got that on the top, and that is applesauce. So I would just picture multiplying everything through by this denominator. It'll leave x minus 4 on the left, and then over here, you get the crisscross. You're going to get a times x minus 5 and plus b times x minus 1. There it is. Now what I would do is strategically choose x. Who are you going to let x be? 5 and 1. And then the answers will fall out nice. So if you let x equal 5, that right there is going to go. So you're going to have 5 minus 4, which is 1, is equal to b right here times 4, right? So b would be a fourth. So there's my b. You might even want to go throw it in right now. B was over the x minus 5. Make sure you put it over the correct one. That's a 1/4. You just put it there on the top. It's going to come out front anyway. Then I would let x equal 1 to get the other one. And watch my arithmetic. As you guys know, that is not necessarily my strong suit, but we're going to go ahead and I feel like I'm being really careful today. Anyway, when I let x equal 1, this whole binomial is going to disappear. I'm going to end up with 1 minus 4 is a negative 3 is equal to negative 4a. So I'm getting a 3/4 for a. Hey, does anyone have their Chromebook open? Anyone? Nobody? Shoot. I was going to have somebody wolfram this. Why don't you open? Thank you. Open it up because it's always good, especially when I'm getting these weird fractions. It makes me uncomfortable, but whatever. There it is, right? So now I'm going to write my answer. What am I going to do with these constants? I'm going to bring them out front. Do I need a fraction correction for either denominator? So you could just answer the question. It'll be 3/4 natural log absolute value x minus 1. It looks so much more complicated than it is. 1/4 natural log absolute value x minus 4 and my good friend Carl. Now I want to see what Wolfram gives for that. Sometimes they don't like fractions, so I'm not quite sure if they might. I don't know. We'll see what it looks like. They might have a more cleanly is that what it is exactly? Pretty. Okay, super. All right, we're going to do one more. I purposely chose, I don't like to do the same types of problems over and over again, so I'm choosing this one right here because of the 2x plus 1 on the bottom. But we're going to start it the same way. We're still going to decompose the fraction. You'll be really happy, some of you, when you get the shortcut tomorrow. I can already know who's going to be nervous and still use these, some of you girls. You won't like the shortcut, Haley. You're going to want to crank it out, be 100% sure yours is right. All right, Rowan's going to use it so fast he's going to make mistakes. So I know you guys so well by now. I know exactly who's in the zone for the shortcut. Some of you, it's too short of a cut and you're going to make mistakes. Some of you, you're going to get nervous. But let's go decompose this. Let's put an A on the top of one of the factors. By the way, just as an aside, I told you we're only doing non-repeating linear factors. Just to give you a little heads up of what you do, like if there were quadratic factors, the tops always go down by a degree. So these are linear, which means the tops are constant. But when you have a second, had this been, don't write it, I'm going to put it in red. Had this been here, that's a quadratic factor. So when you put it down a degree, it's a line. So you'd write ax plus b on the top of this one. That's the only, and you just get more variables. It doesn't get much more complicated. It just gets messy, I guess. So let's go finish this off. What did I have? I had what am I doing? Plus b, right, over x minus 3. So why don't you guys go give that one a whirl? I'm going to pause this. Go give that a whirl. Multiply everything through by the denominator, leaving you x minus 10. So basically you can crisscross the right-hand side. I'm going to pause it. Right, so you should have chose this, and you should have written x minus 10. So go ahead. I'm going to run it through because Olivia was gone, and we leave no man behind, Olivia. All right, so she's sitting there not knowing how to start it. Well, I'll start you off. You're going to do that. Really what you're doing is multiplying through by the LCD, but this is what happens. But keep that in mind for the next one that I do. Then I'm going to strategically, that came out weird, let x equal 3. It'll wipe this factor out, leaving me with a negative 7 from this, 3 minus negative 10. And if I put in a 3 right here, I'm going to get 7b, b quickly, negative 1. That was an easy wipeout, right? The other one, let's go blue here. I'd strategically let x equal negative a half to wipe this sucker out. When I put it in over here, I get negative 10 and a half. I wouldn't write it as that. So instead of negative 10 and a half, let's pretend you didn't have a calculator, you didn't want to do like the 0.5, I'd call that negative 21 halves. And when I put in negative a half right here, I get negative 3 and a half, or negative 7 halves, right? The reason that's way easier is the denominators are the same. So basically the 2's are irrelevant. So what's A got to be? 3. That's why that makes it easier to go top heavy fraction. You don't have to fart around right here. A is 3. So let's go back up and answer the question. Back up to the top. This is going to be, what did we say? It was 3 over 2x plus 1, right? And then minus 1 over x minus 3, or you could do plus and negative if you fancy it. Now, be careful how you write your answer. This would be 3 because it's going to come out front. Natural log, absolute value, 2x plus 1, but what? 1/2 fraction correction. Had this been a u, du is 2 dx. So you'd have to correct that. How many of you caught that one? That's a huge miss, and they always have that. So then it'd be minus, this one is just ln because the derivative of the bottom is just 1 dx. So that'd be minus ln, absolute value x minus 3. One more, and I'm going to let you go work on the worksheet. This next one has something you probably thought you weren't going to use much. I want you to put it on the back of your packet because I don't have room and it's going to take a while. So this one, this is beyond what College Board will probably ask you to do. I already screenshot some out that we'll look at tomorrow so you can kind of see the level that you need to be super competent at, but I'm still going to make you practice some weirdos today and a lot of weirdos tomorrow. So anyway, right here, looks like you can't do it because this is a cubic. So you're thinking, okay, U sub, definitely a big bomb, right? Like not even close. It might be candidate for partial fraction decomposition if I can break this denominator into non-repeating, whoops, I should have put not non-linear, non-repeating linear factors. So let's just put linear factors. Linear factors. And actually, if you could do repeating too, I'm just not going to teach you that yet. So how could I figure out what goes into that? You got to go way back into your math career to figure out how you factor that cubic, because It's not a difference of cubes or a sum of cubes. It's a big ugly mess that's a cubic. So how were you taught, and this would have been in Algebra 2 maybe? How do you attack that and figure out how to factor it? What'd you say, hon? Yes, it's going to go synthetic. It will. But in order for you to break it down to go synthetic, you need at least one factor. So you need at least one number that causes it to be zero. And I just start stabbing at it. I do. I mean, they use the what's called a rational root theorem and stuff like that, but I wouldn't do that. I would just go on here and let x be. It's usually going to be a 1 or a 2 or a -1. You know what I mean? They're not going to make it be 47, you know? So just try things. If you put in a 1, you get 1 plus 2 minus 6. That's not going to give you 0. I'm trying to get a 0. So I want you guys to stab around with it until you get something that gives you a 0. Just plug stuff in. It's quicker than doing it, trying to remember just stab away. And we're trying to randomly find a 0 of the denominator. Plug in a 1. It didn't work. I got 1 plus 2 minus 16 minus 32. That is not 0. Fart around with it until you get a number that'll make the denominator 0. And then tell me what it is. -2 will do her. Let's try it. And it's usually 1 or 2 or -2. I mean, it'd be pretty cruel to make it be something really whacked out, right? So let's go try a -2. That'd be -8, right? Plus 8 plus 32. There, you found it. So -2 caused a 0 in the denominator. What does that mean a factor was? X plus 2. All right, so let's write that over here. It's going to be over x plus 2. That's one of them. So now you do, Rowan, you're right. You do go synthetic division. So it's a good review of that because it's something we haven't used for a long time. I think once in Calc 1. So remember with synthetic, you put that 0 off in its own little, I don't know how you were taught, but I always throw it in its own little box there. Then you write the coefficients. If any are missing, you use zeros. Let's see if you guys remember this. It's good to know. What do? You draw a line. Then what do? Yes, you drop the 1 down. Then what? You multiply here and you add this way. You multiply here, you add, you multiply, and you add. And you better get a 0 or you did it wrong because that was a 0. You know what I mean? What's left gives you will have knocked it down a degree to a quadratic. So this is x squared, x constant. Do you remember that? So this is ax squared plus, Annie can't see what I'm pointing at, ax squared plus bx plus c. So what is your resulting quadratic? X squared what? Minus 16 is what you would have gotten. You could use long division, by the way, if you liked that. You could have done and pulled the x plus 2 and long divided. Most people don't like that, though. And that is a set of non-repeating linear factors. It's x minus 4, x plus 4. So I think I make you do this once on your worksheet, but it's good. Do you see why College Board wouldn't ask you to do this on a multiple choice? It takes a long time, and it really doesn't mean you understand it any better. It just means your algebra is pretty good, and but the actual integration stuff isn't improved any. All right, so we need to figure this out. What I need to do then is break this into 3 pieces. This is what I know. It's going to be something over x plus 2 plus something over x minus 4 plus something over x plus 4. I'm going to integrate it, and I'll go all natural log. I have to find the somethings. So the process is just longer, but not more complicated. I can't wait to show you the shortcut for this kind tomorrow because it will help you. So one last one, and then we will be done. Tomorrow I'll give you a slicker way. So what we're going to do, take and write it down. You have your x over, and then remember we just factored all this. If I show all my work, which I should be a good girl. I'll be a good girl, Mommy, I promise. All right. There you go. That's really what that is, right? And I'm going to decompose it. So really, I should write and show all my work nice and neat. This will drive some of you fast-working boys who write sloppy crazy because you're going to want to skip a zillion steps, then you're going to make mistakes, and then our methodical, neat girls are going to be done way before you are. All right, so remember, I said really what you're doing is multiplying everything through by this denominator, and on the left, it all goes. on the right, this one would cancel and you really get the other two. So this would be a times x minus 4 times x plus 4. You really get the two it's not with. So what would the b be multiplied by? Yeah, it's kind of like crisscross, but all messed up. Like, all right, it's the other two that it's not with. So it'll go like that. And then my c will be with the other two. It'd be c, it's really just fraction. Well, that's why it's called, oh, I can't fit it in. Ah! There. Phew. Now, I'm going to strategically choose x. What am I going to let it be? Start me off. 4, sure. Let's let x equal 4. If I let x equal 4, I get to ignore this because it's going to go to 0. I get to ignore the last one because it's going to go to 0. My resulting equation would be x, 4, is equal to, and all I have left is my b term. So what's that going to be if I put in a 4? 6, 48? Is that right? 48b. Rowan, go Wolfram this for me, please, just to make sure I'm getting 1/12 for b, which makes me nervous, but whatever. I just stole this problem off the internet, and I didn't try it myself. But I'm sure it's 1/12. I don't see any mistakes, so it looks good. All right, what am I going to next strategically choose x to be? Let's do -4. Then it's going to wipe out this one and this one. So all I'm going to have is my c term. So back over here, I've got x right here. -4 is equal to, a's gone, b's gone, the c one's still good. So can someone put in a -4 with a -2 times, is it 16c? Right? You guys know my arithmetic, not so great, right? I'd get a -1/4 for c. Woo! Next up, who am I going to let x be? -2, lots of algebra. Actually, this is easy, though. It just kind of bores me. I don't feel like we're thinking deeply, do you? We're just cranking crap out, but it's kind of fun, I guess. When you put in a -2, this is the last man standing. The other two will go to 0. So you'll say x is equal to a times -6 times 2. I'm getting 12a. Any sign errors on the root, or am I good? So -1/6. All right, I am ready to rock and roll. Back up to the top. A was -1/6. I'm going to go put that right there so I don't have to rewrite it. B was a 12th. C was -1/4. And you guys can write the final answer because now you can do it. That's the whole point. Now you can integrate it without even any more difficult work. +1/6. This was a negative. Thank you. Thank you. See, watch. Okay, there we go. So it'll be answer 1/6 natural log absolute value x plus 2, no fraction correction, plus 1/12 natural log absolute value x minus 4 minus 1/4 ln absolute value x plus 4 plus Carl. Is that what Wolfram said? Sometimes the but it's basically the same thing. Sometimes they'll use the property of logs and condense things. Sometimes, yeah.
Log 4 minus x instead of ln x minus 4. I'm not quite sure why they do that, but they always do that.
And then they raise it to the -1 and bring it, yeah. So so they do this, ln 4 minus x?
No, they do log 4 minus x.
Log 4 minus x? Oh, yeah, it's been programmed to write log instead of ln. That doesn't matter, actually. But, anywho, that one is done. So what's your assignment? Your assignment is to start this worksheet. You're going to try to get 1 through 10 taken care of. I really think you're going to need a separate sheet of paper. Tomorrow, I'm going to start right off the bat with the shortcut, and I'm going to have you do a few of these over again with the short way. You're going to see which way you like better. It's not that I like giving you lots of ways. It's I know some people aren't going to like tomorrow's method, so we need both. All right? So on the worksheet, right by number 10, write stop. I didn't give you enough to even, you don't know how to start the one on the back yet. So let's do 1 through 10. Tomorrow I'll give you enough to do the back. We'll make this worksheet due, is it Wednesday tomorrow? We'll make everything due Thursday. I highly suggest you do it on a separate sheet of paper or it gets kind of, it makes me crabby, but you don't have to. I'm going to stop this, by the way. I'm still talking.